Hello, class. Thanks for coming back, and hopefully you're well and healthy, and you're taking care of yourselves. I'm going to continue with the same format where each week, on Sunday or night or Monday morning, I submit out a learning opportunity where you can try out throughout the week. Tuesday or Wednesday, I'll submit another kind of opportunity where you can go through a website or a different activity. And then on Thursday or Friday, I go through the answers. Well, today I'm going to go through the answers for part 3 of week 2. So that's the Google form that we submitted out on Sunday night or Monday morning. It's based on volume and surface area. So there was, I believe, 7 problems that were in that Google Doc that I sent out. They're based on prisms, regular pyramids, cylinders, cones, and spheres. Let's go through each of these 7 problems. I believe each question had 2 parts. There was like a surface area and then a volume question in no particular order. So let's kind of walk through them and you can see how you did. All right, so first one here's the formula. So hopefully you have these kind of off to the side on your notebook, or maybe you had the video open off to the side and you hit pause. You had to find the volume for this prism. Now this prism that I had in the picture, that's the one in yellow here. This is the problem that we had on the Google Doc. It is a rectangular prism. It's based on a rectangle. I'm going to go through the surface areas. Now you could add up all 6 surfaces, the bottom, the top, the left, the right, on the front and the back, that type of thing. You can add up all those 6 areas if you just found the area of each one of those separately, or you can use the formula that I have here, where you do the perimeter of the bottom, perimeter of the base, then you take it times the height, and then you add the area of the 2 bases. So you can do it that way. So I'm gonna stick with that formula because I think that one's kind of the easiest one, especially since it's printed here. So the perimeter of the base, if I add up, so this the surface area part, I'm gonna add up the perimeter here, and then take it times the height. So the perimeter is the 4 plus 3 plus 4 plus 3. That is the perimeter of the bottom that's going around the bottom. Now I'm going to take that times the height. The height is 3. And then I'm going to add 2 times the area of the 2 bases. And this will give me my total surface area. Now the base, the area of the base is 3 times 4. That's the area of the base. So this ends up being 12 times 2 back here. And in the front, 3 plus 4 plus 3 plus 4. This ends up being a 14 times 3. Now if we keep going here, 14 times 3, what is that? 42. And we're going to add a 24 to it. And we should get 66 total centimeters cubed. That should be the total, surface squared. Sorry, not surface cubed, but surface squared. That is the total surface area. That's every face added together. That should be 66. All right, let's go to the volume now. I'll switch up the colors here. All right, so for volume, you just take the area of the base, which we already said earlier was 3 times 4. That's the area of the base. And then you take it times how tall it is. Well, it's 3 centimeters tall. So 3 times 4 is 12. We're going to take that times 3. And this ends up being 36 centimeters cubed. And that's the total volume for my rectangular prism. So there's question 1 and 2 in your Google form. Let's go to the next page. I'll switch up the colors here again. All right, so we have a sphere now. Now, sphere is easy. I think the easiest formula, we just have the 2. So my surface area formula, you take 4 times pi times my radius squared. My radius happens to be 6 inches, and we're going to square that. So that's 36 inches squared. We're going to take that times pi, and then times 4. Now, the exact answer here, if I take 36 times 4 on a calculator, 36 times 4 is 144 times pi. And this is inches squared. That's the exact area of the surface area of this. That's how many little square tiles would fit on the surface. Or if you took 144 times pi, you get 452.39 centimeters squared. There's your total surface area of that sphere. Now for volume, switch up the colors here. For volume, you're going to take 4/3, so 4 divided by 3, then times pi, and then times the radius cubed. Well, my radius is 6 inches, and we're going to cube that. Now, 6 times 6 times 6, that should be 216 inches cubed. Inches, no, why did I write centimeters earlier? That's weird. Apologies for that. That should be inches squared. All right, so for this one, inches cubed, and then we're taking it times pi. We're going to take it times 4/3. So we're gonna take now the exact answer is to take 216 times 4 and then divide by 3. So I just take the 216 times the top, divide by the bottom. This ends up being 288 pi. inches cubed. That's the exact volume of this object. Now, if you actually want to know what that number is, you take the 288 times pi. And this ends up being 904.78 cubic inches, not centimeters, cubic inches. So that means if you had like imagine a little sugar cube that was 1 inch by 1 inch by 1 inch, right? A little cube. You could fit 904 in that little sphere. That's the idea. That's what volume is. All right, let's move on to the next one. So that was the next two problems on the Google form. Next one, it is back to a rectangular prism again. So we'll switch up the color here. All right, so we're going to do surface area. So we had to find the perimeter of the bottom. So that's 5 plus 2 plus 5 plus 2. That's adding up the entire perimeter of the bottom. And we're going to take that times how tall it is. It's 6 inches. That is, let's see if there we go. 6 inches. We're going to multiply that. And then the 2 times the area of the base. Well, the area of the base is 5 times 2. So that ends up being 10 times 2. And then in the parentheses over here, 5 plus 2 plus 5 plus 2 is 14 times 6. And 14 times 6 is 84. And you're going to add that to 20. And this should be my surface area of this object. So it should be 104. And my surface area is in inches, so inches squared. So again, the formula I'm using here is I'm taking the perimeter times height and then adding the area of the two bases. That's what the capital B stands for. And again, I'm just getting all these formulas directly out of your textbook or online version. All right, now for volume, let me switch up the color here. All right, so for volume, you're going to take the volume, or the base, the area of the base, which is 5 times 2, and then you're going to take it times how tall it is. Well, it's 6 inches tall. So if I multiply these, that's 10 times 6, which ends up being 60 cubic inches. There's the volume. So that's the next two problems. Again, surface area is how many little squares can fit on the surface, and then volume is how many little like sugar cubes or bales you can fit on the inside. All right, let's go on to the next problem. So this was a pyramid, a regular pyramid. Switch up the colors here again. We'll do surface. So we're going to go half the perimeter of the base. So the perimeter of the base is 16 plus 16 plus 16 plus 16. It's a square on the bottom. We're going to take that times the slant line. That's the little L. And I showed you on the picture here, it actually has the slanted line is the one going this way. So that's the 17 in my case. So yeah, take that times 17. And then you're going to add the area of the base. The area of the base is 16 times 16 because it is a square. All right, so adding those 4 16s together, you should get 64. We're going to take that times 17 and then cut it in half, or divide it by 2, if you will. And then we're going to add the 16 times 16, which should be 256 in the back. All right, now 64 times 17 is a 1,088. And you're going to cut that in half and then add that to 256. So 1,088 cut in half, so divide that by 2 is 544, and we're going to add that to 256. And this is the total surface area, so if I add that to 256, I get 800. And that should be feet squared. That's how many total little square tiles fit on the surface of this whole pyramid. Again, it's just perimeter times the slant line, cut in half. What this first part's doing is finding the surface area of each of the triangles going up. That's what it's doing. I know it seems like a weird formula, but that's what it's actually calculating. And then you're just adding the area of the base. All right, let's go to the volume now. I'll switch up the color here. Okay, so for volume, I'll put it up here in the air. So for volume, you're just going to take 1/3 times the area of the base, so 16 times 16. And then you're going to take it times how tall it is, h. The h is the 15. That's the line going up and down in the center. So 16 times 16 is 256. We're going to take that times 15 and then cut this thing in half in the long run. So 256 times 15 is 3,840, and then we're going to cut that in half. So if we divide that by 2, we get 1,920, and this should be in feet cubed. That's how many little cubic feet, or like sugar cubes, if they're measured in 1 foot by 1 foot by 1 foot. So there's your volume. All right, let's go to the next one. We have a cylinder now. Switch up the color again. All right, so for a cylinder, we have our total surface area. So surface area here is 2 times pi times the radius. My radius in my case is 5 millimeters times the height. Well, my height is 10 millimeters. So that's that part, and then we're going to add that to 2 times pi times the radius squared, so 5 squared. So 5 squared ends up being 25 times pi times 2. The 5 times 10 is 50 times pi times 2. And so this ends up being 100 pi up front. This ends up being 50 pi in the back, and this adds up to a total of 150 pi's if you add those two together. If you take 150 times pi, this gives you your total surface, which is 471.24. And that's in, what, millimeters squared. That's how many little squares can fit on the surface of this. What it's actually doing is it's finding the area of the two circles, top and bottom. That's this part. And then the body of the cylinder, like the actual like tubing itself, the whole body is made from this formula. It's a rectangle. It just doesn't look like it. All right. We still have to find volume here. All right. So for volume, we're going to take pi times my radius. My radius is 5. We're going to square that. And then take it times height. So times the 10. So if I take 5 squared, that is 25 times 10. Times pi. This ends up being 250 pi's. That's 25 times 10. And the exact answer here, 250 times pi, is 785.398. And that's in, what, millimeters cubed? That's how many little cubic millimeters can fit in there. Little sugar cubes on the inside. Next one, number 7. Now we're doing a cone of some sort. So again, there's a line going down through the middle, which is the height, and then there's the slant line, which in my case in this one is the 13. So let's kind of walk through this. Let's do the surface area here. We're taking pi times the radius. My radius in mine is 5 yards. Again, this is 5 yards for the radius. That's my R. And then we're going to take it times the slant line, which is 13. That's finding the area of that little cone, the body of the cone. And then we're going to add... this thing will work here. There we go. Wow, it was not working there for a second. We're going to add the circle, the top of the circle, pi times my radius squared, so 5 squared. So this ends up being 25 times pi plus 5 times 3, 5 times 13 is 65 pi. And so this ends up being a total of, what is that, 90 pi's? That's 25 plus 65 is 90. And then if we take 90 times pi, the total surface area is 282.74 little squares, and they're in yards on the surface of this thing. All right, now switching it up, doing volume. Volume of this thing is 1/3 times pi times the radius squared, which is 5 squared, times the height, which is, in my case, the 12 here. Not 10, but 12. All right. Okay, so kind of walking through the numbers here. 5 squared is 25 times 12. We're going to take that times pi and then cut this all on by 1/3. So if I take 25 times 25 times 12, which is 300, we're going to take that times pi and then divide it by 1/3, or divide by 3, if you will. This ends up being 100 pi. If you actually take 300 divided by 3, and this ends up being 314.1592, blah, blah, blah. That's in, what, yards cubed. 314 little cubes that fit in there perfectly. All right, last question. This is the absolute last one. I say this one is kind of the most challenging one that we had. It is actually a prism. It looks like a pyramid. It's not. It doesn't come up to a single point, a singularity at the top. So it is an actual prism. Now, it's just drawn funny. The prism itself is actually a triangle prism. It's a triangular prism. And it's actually drawn incorrectly. It should be drawn where the triangle is at the bottom. This is actually the base. How I know that? The walls that are parallel to each other, that's the little like rectangular walls, that those walls are the heights of an actual rectangular prism. The prism is always based on what its base is. So that's why this is a triangular prism. So if you look at this one right here, this was a rectangular prism, the one in the picture, because I have a rectangle and then there's just straight walls going down that they're parallel. That's how I can tell like what the shape is and how you can classify it. Now that makes a big difference when we're actually doing this stuff. So like the perimeter, well, you have to do the perimeter of the base. The base is 6, 8, and 10. That's the perimeter of the base. So 6 plus 8 plus 10. That's the perimeter of the base, and we have to take it times how tall it is. Its height is the 5. And then you have to add 2 times the area of the base. Well, the base, on this particular problem, the actual base of this picture is actually a triangle. So the area of the triangle is height times, or maybe I should say it's length times width cut in half. 6 times 8 cut in half, because it's a triangle. So you have to find the area of a triangle is height times 8. Height times base cut in half. So this ends up being 48. We have to cut that in half, which is 24, and then we have to take it times 2. So it ends up being 48 again on that part. And in the front, 6 plus 8 plus 10. Let's see, that's what? 14 plus 10, it says 24 times 5. Times 5 is what? 120. We're going to add that to the 148, so that's 168. And that is the total square centimeters that are on the surface. So again, it's the perimeter of the base, which happens to be a triangle, times how tall it is, which is the 5. And then the area of the base, which is the triangle, times 2. Alright, so that's the total surface area. Now volume on this one, in fact, let me change up the color. Volume for this, you have to take the area of the base, which is 6 times 8 cut in half. That's the area of the base. And we have to take it times height. The height is 5. That's how tall this object is. It's not drawn the right way. When I do this, this is 48 cut in half, which is 24, and we have to take that times 5. And so 24 times 5, this ends up being 120. We did that part earlier. That number is the total volume, so it's 120 cubic centimeters. All right, thanks for sticking with me. Sunday night or Monday morning, I'll submit another learning opportunity for you to continue. Hopefully you're staying safe and healthy, and hopefully to see you soon. If you need any help, call me or email me. Thanks.